Hello everyone, good morning. Let's do a very beautiful problem that is based on the calculation of weight average molar mass, the number average molar mass and Pauli dispersity index, that is PDI. So the problem is a protein sample consists of an equimolar mixture of ribonuclease. The molar mass is 13.7 kilogram per mole, kg per mole. That is very giant molecule. You can see 1 mole has 13.7 kg, so it's a very giant molecule. Hemoglobin, again the molar mass is 15.5 kg per mole, and myoglobin, the molar mass is 17.2 kg per mole. Now we have to select the true statement about the weight average molar mass, the number average molar mass and Pauli dispersity index for this sample, and these are the four options here. Now, so first we have to write what? Molar mass of ribonuclease, and its molar mass is what? 13.7. Hemoglobin, and it is what? 15.5. And one is myoglobin, and its molar mass is what? 17.2 kg. Okay, now let's do first calculate the weight average molar mass. Now, so weight average molar mass, that is MW bar, is given by summation of Ni mi square upon Ni mi. So this is the formula for the calculation of weight average molar mass, where N is the number of mole of the corresponding molecule and M is the molar mass. So we can simply say, if they are taken equimolar, then you have to consider equal mole for each of these species. Either you can take 1 mole each, or 2 mole each, or 3 mole each, but whatever you are taking, whether you are taking 1 mole each or 2 mole, it should be equal for all. That is, let's take 1 mole of ribonuclease, then you have to take 1 mole of hemoglobin as well as 1 mole of myoglobins. So answer will be same if you are taking 1 mole each or 2 mole each. So now for simplicity, let's take 1 mole of each, these molecules. So in the first we can write MW bar, it will be 1 into 13.7 square, so 13.7 square, plus similarly 1 into 15.5 square plus 17.2 square divided by 1 into molecular mass of 1, that is 13.7, plus 1 into molecular mass of second, that is 15.5, plus 1 into molecular mass of third one, that is 17.2. Now if you will solve it, I have already solved it, and if you solve it and add it now, you will get 723.78, and if you solve this, you will get 46.4. okay, now after this you will get 15.59, that will be in kilogram per mole. So that is the weight average molar mass, that is 15.59, or you can say 50.6 approx kilogram per mole. Now let's calculate number average molar mass. So now let's calculate M in bar. Now for this we know the formula, that is NiMi divided by summation of Ni, that is number of mole into their molar mass divided by the sum of the number of moles. So again we know that NiMi was 13.7 plus 15.5 plus 17.2 divided by, we have taken 1 mole of each, so 1 plus 1 plus 1. If you add them you will get 46.4 divided by 3, and if you will solve it you will get 15.46. Now the last one is polydispersity index. So polydispersity index PDI is given by weight average molar mass upon number average molar mass. And now weight average molar mass was 15.59 and it is 15.46. If you will solve it, so the answer will be, suppose numerator is greater now, that is 15.59 divided by 15.46, it is around 1.008, so that is greater than 1 basically. Now let's see the options. Now first is weight average molar mass should be greater than number average molar mass mn bar. Yes, this is correct because 15.59 is there and this is 15.46, as well as mn number average molar mass is equal to 15.5, so this is 15.46. when you will round it off it will be equal to 15.5, so this is also correct. And polydispersity index is greater than 1. Yes, we are getting PDI greater than 1, so yes, option A is correct in this case. So see it. So these type of questions are also asked in GATE, and generally in the polymer chapter is that we have the GATE previous year problem based on this that has been asked in GATE also, and generally in every year this type of questions, one questions from this type come in GATE examinations or asked in GATE examinations. So you must know these formulas and how to solve it. Okay, so that's the end of this lecture now. Thank you very much.